This example comes out of section 8.4, log and exponential equations. Now this one is about as complicated as our exponential equations are going to get in Math 30, just given that it's got numbers that can't be written as same base, so we can't just write everything as a power of 2 or 3 or 5 here. We can't divide by 2 to get rid of that 2 from one side without making the other side more complicated, so we're kind of stuck with what we've got. And so this definitely is, if we're going to answer this with an exact value, we're going to log both sides of this one. So log of this whole thing equals the log of this whole thing. Notice I was a little extra careful with the brackets on the left side there. It's log of 2 times 3 to the x plus 1. It would be wrong here to bring the x plus 1 down in front of that whole expression. On the right side, it's completely correct to say it's 2x minus 3 times log of 5, as we did in a previous example. But this x plus 1 on the left side is not an exponent on the 2. The way that we avoid making that mistake, which is essentially an order of operations mistake, is we separate this into 2 logs. Log of 2 plus log of 3 to the x plus 1. That agrees with our log rules, our log laws, and what it allows us to do in the next step is we do end up bringing down this x plus 1, but notice that it's only being multiplied by the log 3. And like I said, that is by far, when I mark questions similar to this on quizzes and tests, this step right here is definitely the step that the most mistakes will be made on. Now from here we have a very similar question to our last example we did, where we need to get rid of these brackets. We've got x log 3 plus log 3, and these brackets, so 2x log 5 minus 3 log 5. Combine all the x terms on one side and all of the non-x terms on the other side. I like to go as fast as possible, so I'll leave these 2 terms on this side and just add the 3 log 5. And I've got 2x log 5 minus x log 3. You would still get a perfectly correct and equivalent answer if you brought all the x terms to the other side and all the non-x terms, switch them around. You'd have a lot more negative signs. Every sign basically would be reversed from what we have right now. Our next step though is to factor out the x. I've got 2 log 5 minus log 3, and I have log of 2 plus log of 3 plus 3 times the log of 5. Again, we could combine those and make it a little tighter, but we'll do that at the end. It would be just fine to say that this x is equal to this big expression on the left divided by what we had in the brackets there, 2 log 5 minus log of 3. And that would give you an answer equivalent to if you just tried a graphing solution right off the at the start. You could write this thing a little bit neater again as combining all these logs on the top as 2 times 3 times 5 to the 3, and on the bottom having log of 5 squared divided by 3. And again, those could be even made to look a little nicer than they are, given that you could say 2 times 3 is 6, and 6 times 125 is 750 or whatever, but these answers both would be, in my quizzes and tests, acceptable as exact value answers. Now, what does x equal approximately requires a second on the calculator. And whether I try the expression on the left or the one on the right, I'm getting approximately 3.12. Again, the same answer you would have gotten had you graphed the left side and the right side of the original equations and just found their intersection. But the exact value answers were required for the solution, so the algebra was required too.